Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So guys, today I'm going to cover that what is the difference between abstract class and interface. We need to know that, okay, what exactly the meaning of abstract class, what is interface, what is the actual difference between abstract class and interface, and when we have to use abstract class and when we have to use, interface, whenever we have to design the code and whenever we have to design the framework. We should always know that, okay, what is that exactly the actual purpose of abstraction and abstract class and interfaces. Okay, so let's do it. So I have this particular Java project, and in this particular Java project I'm going to create a new project, new package. Let's see, my package name is Abstraction. Okay, so both abstract class and interface is used to achieve the abstraction. Abstraction is one of the important concept of object-oriented programming concept, and it is available in most of the programming languages. So that's why I'm writing that abstraction concept. Okay, let me write like this: abstraction concept. So now, after creating this particular abstraction concept, I'm going to create first. First, we will learn about. We will check what do you mean by abstract class. Okay, so I'm going to create a class, and let's see, my class name is I'm going to create one abstract class, that is, let's see, bank class. And don't select the main method, I'm just creating one simple class, and click on finish. Okay, now what we have to do, okay, public class bank, this is a normal class, but if you want to define is this is as abstract class, we have to use one keyword. That keyword is called abstract keyword. Okay, public abstract class bank, now it is a abstract class, but there are some rules. So whenever you have to define a particular abstract class, in abstract class, at least one method should be there. Okay, one method should be there which is abstract in nature. So what do you mean by abstract method? Abstract method means only prototype, no method declaration, only method declaration, no method body. Okay, so let's see. I'm going to create one abstract method, public abstract void, let's see, clone. Okay, so this particular abstract method, if you give method body like this, it is not allowed. So what you have to do, guys, only and only method prototype is allowed. This is called abstract method. Public abstract void loan, this is abstract method. Let me write it. Okay, abstract method means it does not have any method body, no method body. Okay, so I have created one abstract method, as well as now I can create some non-abstract methods also. So this is the advantage with abstract class, that you can have multiple abstract methods, you can have multiple non-abstract method, but at least one abstract method is compulsory. Okay, if a particular class is abstract class. So let me define one non-abstract method. Let's see, public void, I'm going to define, let's see, credit method. Right, now this is non-abstract. Why? Because I haven't written any abstract keyword over here, and this method is having its method body also. Let's see, I'm printing something, system.out.println. I'm going to write bank credit. Now let me have one more method, public void debit method. In this particular debit method, I'm going to, again, this is non-abstract method, I'm simple write bank debit. Right, so this is called abstract method. This is these two methods are called non-abstract method, because I haven't written any abstract keyword over here, and these two methods have okay, their own method body also. Now this abstract method, okay, whatever the abstract method I have written, loan method, okay, this is called abstract method because it does not have any method body. So this is the structure of abstract class. Now what I'm going to do in this particular abstract concept, I'm going to create one more class. Let's see, my class name is SDFC. Okay, SDFC bank, and click on finish. So currently, what is the relationship between SDFC bank and bank? No relationship. But what I want, this SDFC bank, okay, should be the child of bank class. So I have to use extends keyword. that we have already covered the interface part, sorry, inheritance part, extends bank. Now it's giving you one error that if you read this particular error, it's saying that in SDFC Bank must implement the inherited abstract method bank.loan method. So here is a concept, guys. Whenever you are going to implement any abstract class or whenever you are going to extend any abstract class, it means SDFC Bank is the child of bank class and bank is abstract in nature. And in bank class, we have one abstract method that is called loan method. Now it's SDFC Bank responsibility to define that particular loan method in this particular class. So how I'm going to define? Simple like this: public void loan method, and here I have to give the method body. So simple, I'm writing, let's see, system.out.println SDFC loan method. Okay, SDFC loan method I have defined over here. Right, so this is the loan method which I'm going to override from abstract class bank class. Okay, same method name loan, 0 parameter, same method name loan, 0 parameter, available in bank class as well as in child class SDFC bank class, is called method overriding. I'm going to override. So the moment I override, SDFC bank is not giving any error. The compiler is not giving any error. So this is the concept, guys. Tomorrow, if you define one more abstract method over here, it's your responsibility to define inside the SDFC bank one more abstract method you have to define over here. Right? Now, what is the advantage? SDFC bank says that, okay, fine, we will extend you, and whatever the loan method you have defined as an abstract method, we will define the same method, but we will write our own business logic. Let's see what is the loan interest, what is the loan amount, home loan, what kind of loan, education loan, car loan, vehicle loan, right? Different kind of personal loans we can define according to the SDFC bank. Bank says that, okay, if you are going to extend me, okay, I'm having this particular loan abstract method, now it's your responsibility to define this particular loan method in your class. And other method you don't need to define. This is the biggest advantage, guys. Credit and debit method I don't need to define over here. Credit and debit method I'm going to, okay, I can directly inherit from bank.java class. Okay, now I'm going to test this particular feature. So how to test? Simple, I'm going to create a new class, and let's see, this is the test bank class, and select the main method and click on finish. Inside the here, what exactly I'm going to do, I'm simply going to create the object of SDFC bank. So simple, I'm going to create SDFC bank. Let's see, HB is equal to new SDFC bank. Sorry. Okay, so this is the object and HB is the reference. So what I'm going to do, can I access HB dot credit method? Yes, HB dot credit method directly coming from here. Okay, it's directly coming from bank.java. Can I access debit method? Yes, HB dot debit method I can also access. Can I access HB dot loan? Yes, now I can access HB dot loan also. I can directly access from SDFC bank because this is a overridden method. I have already overridden this particular method. So this is a concept of method overriding, and this is a concept of abstraction. Now what exactly I'm going to abstract over here? See, abstraction means, what do you mean by abstraction? Abstraction means, guys, that to hide some implementation logic. I have defined one loan method over here, but I'm not going to define any implementation logic over here. Implementation logic will be defined by the respective child classes. SDFC bank says that, okay, fine, we will override this particular method, but what kind of implementation logic, what kind of interest rate, and whatever the feature we are going to define, the implementation logic and implementation feature will be defined by SDFC bank. Now let's say tomorrow ICICI bank says that, okay, we are going to override this loan abstract method, but the implementation logic we will define according to our bank policy, right? Same thing we are doing over here, that a loan method is defined just a method prototype, simple method declaration we have done. We are not going to define any method body. It means this particular method is not common. Okay, the logic of this particular method is not common for all the implemented classes, all the child classes, but credit and debit feature is common for all. So this is called partial abstraction. Okay guys, always remember this is called partial abstraction. So through abstract class we are not achieving 100% abstraction. We are achieving partial abstraction. Let me write partial abstraction. And now what do you mean by abstraction? Abstraction means, to achieve abstraction means hiding the implementation logic. It's called abstraction, right? So this is called partial abstraction, means that this particular method is abstract in nature, but these two methods are is common for all the child classes, right? So no need to define these two methods inside the child classes. We can directly inherit from here, but we have to define loan method in respective child classes. That's why this is called partial abstraction. Okay, and this is how we are going to test this particular feature. Now tomorrow, same, if you want to achieve dynamic polymorphism also. What do you mean by dynamic polymorphism? That I'm going to just create the object of SDFC bank like this, SDFC bank, without reference. Okay, this is the particular object got created inside the memory without any reference, but which can be referred by bank class interface also, guys. We can write like this also. Bank B is equal to new HDFC bank. Now if you call all the method b dot loan method, yes, I can call b dot loan also. Can I call b dot credit? Yes, I can access. B dot debit, yes, I can access, right? So if you run this particular program, see, all the methods are getting called respectively, right? So through dynamic polymorphism also we can call all the methods, all the overridden methods, as well as the inherited methods also we can call. Same thing for normal class object also, we can call all the three methods. Now tomorrow SDFC bank says that okay fine, we will define loan method and credit and debit is coming from the child class. But tomorrow SDFC bank says that okay, we have some extra features also which we don't want to expose to anyone. So let's see, we have one method, let's see public void, let's see funds method, and then system.out.println, I'm simple writing SDFC funds, right? Now tomorrow I'm going to create the object of SDFC bank. So simple, by using hb.funds I can call that particular method. Can I access b.funds over here? b.funds is not available, guys. Why? Because funds method is only part of SDFC bank. Okay, and this particular new SDFC bank object is referred by bank interface, bank abstract class reference variable, right? So by using this b, I cannot access funds, because this is the SDFC bank says that okay, we have our special method, funds method, which cannot be accessed by any other reference except SDFC bank reference variable. Here you are creating the object of new SDFC bank, that is fine, but which is referred by bank B. B is the reference variable, okay, of that particular object. So through B is the reference of bank class. I cannot access funds over here. So always remember this concept, okay, that b dot funds we cannot access. But by using this SDFC bank HB reference variable, I can access all the methods. So these two methods are coming from parent class. This is the method which is the overridden method, and funds is the non-overridden method which is only available in SDFC bank class. So like this, we are trying to achieve abstraction, and this kind of abstraction is called partial abstraction, because in bank class I have one abstract class, abstract method, as well as non-abstract methods also. So these are called non-abstract methods. Okay, these are non-abstract methods. So what do you mean by abstract class? Abstract class, okay, can have abstract methods as well as non-abstract method also. So let me write this particular abstract class can have, I'm simple writing ABS abstract methods and non-abstract methods. Okay, this is the thing. Okay, so this is called abstraction. Now what is interface? Let me create quickly one more interface over here. Let me create one interface over here, that new, let's see, my interface is car is the interface. Okay, and this particular interface will be created. So inside the interface, whenever you have to define the methods, we have to achieve full abstraction, 100% abstraction we have to achieve. It means in interface, I can have only and only abstract methods. Okay, so in interface, I just need to write like this: public, let's see, void start method. Public, no method body, guys. In interface, method body is not allowed, because in interface all the methods are abstract in nature by default. No need to write abstract keyword also. Interface method means no method body, very straightforward. Public stop method. Let's see, I have one more method, public void refuel method, right? So public void start, public void stop, and public void refuel method. These three methods, these three abstract method I have defined. So in interface we always define, okay, we always define only abstract methods. What do you mean by abstract method? Abstract method means no method body, no method body, only and only method declaration. Okay, only and only method declaration, and no need to write, okay guys, no need to write abstract keyword also over here. And this is how we achieve 100% abstraction. Okay, we are not going to define any business logic inside the interface. Interface means only prototype. Okay, only simple prototype, the blueprint you are defining, that a particular class can have start method, stop method, and refuel. Simple blueprint we have defined without any implementation logic, that what kind of logic we have to write for start method, stop method, and refuel method. Now tomorrow if you're going to implement this feature, simple, I'm going to create a class. Okay, let's see, my class name is BMW class. Click on finish, and this BMW, if you want to create that, the BMW is a child of car interface, so you have to use implements keyword. Implements car. Now again, it's BMW responsibility that you have to override all the methods which are available in car class, which are available in car interface, not class. Start, stop, and refuel, right? So if you mouse over, it says that okay, add unimplemented methods. Simple, you have to define all add unimplemented method, that is start method, stop method, and refuel method you have to define. So start method means, let's see, simple, I'm writing my own logic over here, that system dot, that BMW start. Simple, I'm going to write system dot out of println, I'm simple write BMW stop and BMW refuel method. Refuel method, right? So, and this is the at the rate override annotation defines that. It's not compulsory that okay, you have to write at the rate override, but it is a good practice if you write at the rate override method, that this start method is okay, is the overridden method which is coming from car interface reference variable. So start, stop, refuel method should be defined over here. So now you can see that I'm not going to define any method declare, any method body, no implementation logic. It's completely fully 100% abstraction I'm going to achieve over here. Same thing, I'm going to implement the same all these three methods over here. Now the implementation logic according to the BMW, what kind of a start method you have to write, what kind of a stop feature you have to write, what kind of refueling method you have to write over here according to the BMW. Now tomorrow, let's see, Audi class is available. The Audi is also implementing car. So Audi will define all these three methods, start, stop, and refuel. It's compulsory to define all these three methods in Audi class also, as well as in BMW class. And the respective class will see what kind of implementation logic we are going to define. So at the interface level, we are not going to see any kind of implementation logic. So that's why this is called 100% abstraction. We are going to hide the complete implementation logic over here. Just a method prototype we are going to define only and only the blueprint of the methods, blueprint of the interface, the car interface we are going to define over here. So this is the basic difference between abstraction and okay, partial abstraction as well as full abstraction, and abstract class versus interfaces. Always remember that in interface, as well as if you see in testbank.java, if you try to create the object of bank class like this, bank b1 is equal to new bank, this is not allowed. Why? What exactly it says that, okay, cannot instantiate the type bank. Why? I cannot create the object of abstract class. Always remember, guys, cannot create the object of abstract classes. We cannot create the object of abstract class. Same thing, I cannot create the object of car interface also. Cannot create the object of interface as well. So both are abstract in nature. Interfaces as well as abstract classes, both are abstract in nature. And whenever you see abstraction, it means I cannot create the object of abstract class as well as interface also. Okay, and in interface, no need to write abstract keyword. It is okay. Interface keyword is generally used, and automatically these methods will be declared as, automatically it will be understood as abstract methods. Okay. Now, apart from that, if you inside the bank, okay, in this particular class, if you define that it can have any kind of variable, it can have final variable also, it can have non-final variable also, static and non-static variable also, we can define over here. Like I can define simple int, let's see, amount is equal to 100, okay, or let's see, I can simple write final rate is equal to 10 and final int rate. So final keyword also I can define over here. Okay, or static variable also I can define. Let's see, static uh, loan rate is equal to 5% like this. So static variable also I can define over here, and non-static variable also I can define over here. So this is non-static, this is final is, okay, this is a final method, and this is a static, I mean final variable, and the static variable also define I can over here. But in interface I can have only static and final variables. So in interface, if you're going to define only and only final and static variables I can define. Only final and static variables are defined. It means I can define like this, final, and let's see, int wheels is equal to 4. Okay, and by default these, you don't need to write final also, guys. If you write int wheels equal to 4, by default this wheels will be okay, will be treated as final and static. Okay, so now if you try to test this particular feature, now see, let me delete this, so I cannot create the object of bank abstract class also. Now if you try to test this particular interface, so what I'm going to do, simple, I'm going to create one class. Let's see, test car class having the main method, and simple, as you know that we cannot create the object of interface, so I'm going to create the object of BMW. BMW B is equal to new BMW. Okay, and by using this b dot, can I access start method? Yes, I can access start. Can I access b dot stop method? Yes, I can access b dot refuel. Yes, I can access. So I'm going to access all these three overridden method, and if you run this program, see, BMW start, stop, and refuel, all these three methods are getting called. So these are the three overridden method inside the BMW. Now BMW says that, okay, fine, we are going to override these three methods, start, stop, and refuel, but I can have non-abstract method also. I mean, forget about non-abstract methods, non-overridden method also. So what do you mean by non-overridden? Means I can have my own method also. Let's see, public void and theft safety method, and which is only and only available in BMW class. Theft safety, right? So I can I call b dot theft safety? Yes, I can call b dot theft safety because I'm going to access by BMW class object. Same thing if you try to achieve dynamic polymorphism, it means child class object new BMW can be referred by parent interface reference variable also. So I can write like this also, car C is equal to like this. This is called dynamic polymorphism or top casting I'm doing over here. Parent child class object can be referred by parent class reference variable or parent interface reference variable is called dynamic polymorphism. So can I access C dot start method? Yes. C dot start method. C dot stop method? Yes. C dot stop. C dot refuel? Yes. C dot refuel. C dot theft safety? No. Again the same thing. C dot theft safety feature is only and only available in BMW class, and BMW will not allow this particular method to car reference variable because this particular object is referred by car C, and C cannot access C dot theft safety because this is the only specific feature. Okay, there is a security constraint that okay, this is the only specific feature to BMW, and BMW will not allow to any parent reference variable to access those particular methods, which are only and only applicable for BMW. So always remember these concepts, guys. These concepts are really important. Okay. So now when to use abstract class and when to use interface. See, guys, whenever you have to achieve the partial, you know, the partial abstraction, in that case we have to use abstract class. Some implementation logic we want to define for which is a common logic for all the classes. In that case, you can define like this: the credit and debit, which is common for all the classes. In that case, okay, and some features we want to define non-common method, which is implementation logic we want to hide some important feature you want to hide. Let's see, the loan percentage should be defined by respective banks, so I'm going to create as abstract class. But credit and debit, these are the common methods for all the classes. In that case I'll be using abstract non-abstract methods in that case. So obviously I have to use abstract concept, abstract class concept. But interface we have to use only and only when you want to hide the complete business logic, the complete implementation logic or feature you want to do. Okay, you want to hide, you don't want to define in the form of interfaces. In that case, in the form of abstract classes. In that case we have to use interface, because no one can access, no one can read what kind of a start, what kind of a stop, and what kind of refuel. Tomorrow, BMW can implement start, stop, and refuel according to their features. Audi, Mercedes, Honda, other classes, other classes, which are the child of car interface, can define the respective features, start, stop, and refuel according to their feature, according to their business logic. So whenever we have to achieve the 100% abstraction, 100% implementation logic we want to hide, in that case we have to use, okay, we have to use interface. But whenever you have to use partial abstraction, in that case we have to use abstract classes. Abstraction means to hide the business logic or to hide the implementation logic is called abstraction. This is the concept of object oriented programming, oops concept. Okay, so this is the thing. Performance wise, guys, if you see, the performance wise abstract classes are faster than interfaces, because in interface if you try to achieve with the main method, if you try to call okay all these methods like this, it will see that okay, where exactly the start method is available over here, and this start method implementation is available inside the BMW. Okay, for traversing point of view, in the Java heap memory point of view, it has to iterate first. It has to go to the uh, to the parent interface, then from parent to the child implemented classes, and then it will come over here and then it will execute this particular method. But in, if you see in bank abstraction, for loan it is fine, but for credit and debit, immediately it will come over here and it will try to execute the logic which is written inside the credit method. Okay, so that's why the performance wise, okay, and some feature you want to hide, some feature you don't want to hide, in that case abstract classes are faster than as compared to interfaces. So whenever you have to define the framework and you don't want to you don't want to hide any feature, okay, in that case you just need to define that or some feature or maybe 20% feature you want to hide. In that case, you can use abstract classes, but the full 100% feature you want to hide or implementation you want to hide, and the respective child classes should do that. In that case, you have to use interfaces, guys. So this is the basic difference between abstraction, full abstraction, and partial abstraction interfaces versus abstract class. It's a very important interview question. People will ask you what is abstract class, what is interface, when we have to use abstract class, when we have to use interface. With the practical example you can give like this. Okay, so thanks for watching this particular video, guys, and let me know if you have any issues. You can write all your comments and queries and okay in the comment section, and definitely I will try to reply over there. And please subscribe to the channel. My channel name is Naveen Automation Labs, and let me know if you have any issues. Please share it, like it, and share with your friends and colleagues. Thank you so much, and thanks for watching.